why the code keeps breaking, what does this code do? Maybe this developer is trying to review some code and they have no idea what does that code do because it was not very well written. How to provide business value. What should I store? Should I have historical data or not? Who changed that code? Maybe they don't have version control code repositories. Why the business keeps finding errors in the data, and most importantly, why nobody trusts the data we provide. This data engineer was struggling with all of this before they had an idea. What if they had a process that would allow the business to give input and they would be able to provide more business value and also have more control over their data environments? The video is going to talk about provide business value with data and by simplifying business value with DataOps. So first of all, we're going to talk about what is DataOps and then how to apply DataOps principles with real life examples. First of all, what is DataOps? So this definition is by Monte Carlo, and basically DataOps is a way to support an organization data needs and provide analysts and other downstream stakeholders with reliable data. That sounds very optimal, but let's try and make this more specific. In my view, a bunch of DataOps is a bunch of best practices around code and collaboration that takes time to implement. It's not something that you can implement in a week or in a month. It demands prioritization and culture. It's that the type of thing that usually is not urgent and we don't prioritize it, but it makes life easier by having it. So by having integrations run smoothly, for example, processes for collaboration with data users, error catching, and atomic code. And also it helps with some holy grails of data engineering, with which are having a source of truth and have self-service. But how to actually apply the DataOps principles, because that all sounds very optimal, but also not very realistic. So these principles help not necessarily arrive to that state. No, the goal is to arrive to that state, but as I said, it's long term. So all of those combined with time take to the optimal state of data collaboration and business value and providing business value. So the first principle is having ELTs instead of ETLs. ETLs usually you extract data, transform, and then load. And in this case, we have extract, load, and then transform. And that allows for data lineage. You will have the data before you transform it. That also allows for audits, and both concepts enable data governance and understanding more about your own data. And you can also have historical data as you are loading the data before transforming it. And how to apply this in an event-based system. For example, if you're ingesting data uh, from Kafka, you can have an ingestion or landing zone where the data will um, be arriving at it in its raw state to your landing zone, and then you have the whole data uh, kept there before you transform. You can also add, if you already have ETL, you can also add a load function before the transform, so it will be ELTL, but that will also apply the concept of having historical data, having data lineage with your raw data. And also another approach is using node code tools to extract. That will facilitate your your work in general, because if you have no code, you won't have to hard code your extracts, and it will work just fine. Just like Arabyte, you can extract your data to an S3 bucket, for example, and then you use Python or DBT or whatever to transform your data from that point on. Also, a small t before loading might be necessary due to data regulations such as anonymizing data or even deleting data from users that requested that. Another principle is governance and change control. What does that mean? Changes what are the advantages? Changes are properly reviewed and tested. Rollbacks are a possibility. Basically, a code versioning tool such as GitHub for both data and code, because it's very important to have these possibilities with data as well. So how to apply? Use GitHub or any other tool for managing your data pipelines, your data infrastructure code, maybe like Terraform, uh, and you can version control that. You will know who uploaded the code, and you will have the possibility of having a rollback. Um, as you're using this type of tools, it's important to implement pull requests and code reviews. If you're alone, even if you're alone, if you're a team of one person, you can have some processes for yourself to review your code and to create pull requests. But for teams with other people, it's very interesting. So people find errors in the code of others and also know what's happening other than their work. Automate testing to catch data and code errors before deployment. So have automated testing, which is another DataOps principle I'm going to talk a bit more about. But when we have these type of repositories, it's very easy to have these processes for automated testing. And as we'll have more people looking into this code, continuously verify the compliance with data regulations. If you're deleting what is required to be deleted, if you're anonymizing what's required to be anonymized, and this type of stuff will help your data governance and governance in general. Another principle is code design and maintainability. Basically, you should have your code. Your code should be easy to read, test, and reuse. And these are some ways to apply that. For example, you can avoid duplicating the transformations across different pipelines. If you have a transformation in the same piece of code in multiple pipelines, you should have like a package or something that you import into your file, and then you can just use that. Break down complex ELT logic into small reusable functions. For example, you can have a function for extract, one for load, one for transform, and that way the data flux is always clear. There is always clarity in the data flux, always extracting, loading, and transforming. Use parameterized functions instead of hard coding values. That's very important to be able to do the two examples above. If you want to avoid duplicating code, you need to have parameters that you pass to these functions. Follow consistent naming conventions. As I said, you can forget things that you wrote. So it's important to follow consistent naming, and also other people can read your code more easily. So trying to have simple but meaningful things while naming your variables, your functions, and follow your standards if you have them in your company. Document functions with doc strings and comments. That will also help people understand what's being done in that code, being that you or other people, and ensure clarity in data flow. Always the same structure. Always, for example, if you are using ELT, always extract, load, and transform. Don't try to switch it up, else the code readability and the data flow itself will be a bit more complex, and we want things to be easy and simple. Another principle is testing. As I said previously, I was going to mention this. The advantages are prevent bad code in production, prevent messing up data in production, and breaking downstream products such as dashboards or models. Um, and how to apply. So in this case, you need to have your atomic code to be able to validate isolated pieces of logic. For example, if a function correctly normalizes a column's names, you can check if you can do a test that will test that function easily if it's that isolated piece of logic. If it's a big function, that won't work. That does a lot of things. Prevents schema drift by verifying column names, types, and constraints. For example, if you have a created at field, you want that always to be a date type or timestamp. Check for nulls, duplicated records, outliers, incorrect formats, and ensure new updates don't break the existing logic. Another principle is CI/CD. So the main advantages are automating integration, testing, and deployment. That helps with faster deliveries, with reduced manual efforts, and also human errors. And how to apply that? CI/CD is very simple to apply. It's just you just have to understand your workflow and then automate part of it. So and also implement best practices. So you perform unit and integration tests automatically before allowing merge. That will block some bad code and also some bad transformations, things that alter your data in a way that you don't want to. You may use linters to assure code quality before merging. And also, as I said, map step by step how to upload code to correct environment, would you do that manually? And then you create automated steps for the deployment on merge to main branch. So after you verified if the code is integrating well and it's not breaking anything, at least that you have tests for, you assured code quality with linters, you can deploy your code, which is continuous integration, continuous deployment. Environment management is another principle. Basically enables verification in environments that mirror production. It reduces the risk of breaking downstream products and allows for environment isolation, because you won't be deploying every pipeline in production. You will be deploying in staging or in development. That won't break your production dashboards. That won't affect and data end users. How to apply that? Having a production, staging, and development data environments, found databases, and for development and staging mock data. Mock data is also like very complicated to be adding to staging. Maybe keep that only in development, but some companies use mock data in staging as well. Use separate branches for development, staging, and production. That will allow for code isolation. And you should also always sync your environments to ensure consistency, because else you have your development branch not up to date to production branch, or your code in production you don't have your code just like in production, to test and development, which is something that will not be optimal. And automate and document environment setup. You don't want to be like creating the setups manually, because else you can forget some configuration that you did in production but you did not in development, for example. So if you have Terraform or another infrastructure as code language setup, you be able to only change some names, for example, the name of the environment itself, production and development, and you'll be able to deploy that in seconds. So also something that we don't prioritize because for the sake of time, but in the future will affect you maybe. And monitoring, uh, it enables the early detection of issues in data pipelines. It catches errors in production before the end users are impacted. So the early detection of issues in the data pipelines are not only for data pipeline runs, if it failed to run, for example, but also in data itself. Maybe that pipeline ran, but your data was not correctly transformed, and that will impact your end users. You may have some monitoring to detect that. And so set up automation for alerts on pipeline failures, crucial for maintaining the health of your data pipelines. Implement real-time monitoring with dashboards that can be about your data itself or the logs for your data pipeline runs. Integrate monitoring with log management tools. Uh, this way you can actually make data-driven decisions about your data pipelines. If you have the logs, which is basically capturing data about your data pipelines, in the future you'll be able to have data-driven decisions about that if necessary. And also integrate data quality checks into a monitoring system to alert. As I said, you should test your data, and then by doing that, you should also have monitoring systems to alert you in the case that these tests fail. But that's basically it. And last but not least, DataOps principle is collaboration and self-service. So data users having an increased productivity due to data democratization. This way they have self-serve and they don't need to keep asking you for data or something, and then they can get along with their work and not be blocked by you. And they are also incentivized to provide feedback and collaborate in projects. That way we will have the business value that we talked about. If we don't have users inputs, that may be harder to do. So set up a self-service data platform, having a data catalog, and provide teams with correct access to data. So having a data catalog is very important in this step, because if you have data, they have access to data, but they don't know what the data is, they will be pinging you wanting to know what is that data or what should they look for. So having a data catalog is very important in this case. Also, providing teams with correct data access to data is very crucial in a world that we have increased data regulations. Also, it's important to have that in mind and maybe have trainings for the teams about data regulations, how to handle data, how to share data, if to share data, like if they should be sharing data or not, what types of data they could share, that type of stuff, and with who. Create cross-functional collaborative environments, incentivizing feedback about data. That way, it will be easier to actually provide business value, and empower teams with analytics and reporting tools. Maybe have a training about them so they can actually leverage these tools. Maybe you have a tool, but you haven't help them, enable them to actually be using them, the tools. So it's important to have that in mind as well. So, summarizing, a lot of principles, but basically they are best practices with code, integration, and collaboration. They set data teams up for success. They take time and culture, but pays off. As I said, all of these things, or many of these things, are things that we don't prioritize, usually because they are not urgent, but in the long run, they will help an organization, a data team, to provide business value to an organization. And again, long-term thinking. This is not something that you will be implementing in a week or in a month. It's something that requires long-term thinking. So if you want to chat more about data ops, reach out in our email or schedule a time. The info is in the description, and thank you for your time. Hope to talk to you soon.